Hey, welcome back everybody. So in this video, we're going to start practicing graphing lines. We've practiced graphing points. Now we're going to start graphing lines in a variety of different ways, and that's going to be the majority of the unit from here on out. So bring up those guided notes. We're going to go ahead and start filling those in. So this is graphing by table and slope guided notes. Okay, so remember we were talking about functions before. A function is simply a relation. It's basically a bunch of points on a graph, but for every x, there is only one y. So if I connect the dots, well, I can't. If I do a vertical line test on these, I'm only going to go through one dot for each vertical line that I make. And these aren't perfect vertical lines, but you get the idea. So that's a function as far as a graph goes. It can look a variety of different ways, but so long as it doesn't bounce around, like let's say I tried to connect these a different way, this isn't going to work. It's going to fail the vertical line test because I can go through it more than one time as I pass a vertical line through it, and so it fails that vertical line test. So it is not a function. You guys remember doing that? If not, go ahead, go back, take a look at that. So the idea that we have is that on our graphs, it's not going to be stuff that looks all wibbly wobbly like this. This would also fail the vertical line test. It's going to look more like, if I bring my graph back, all of our lines in this chapter and throughout the year are going to look something like this. In Algebra 2, you'll start, an intermediate algebra, you'll start dealing with curved lines, and actually I guess you'll start that in geometry as well. But these are still going to be functions. So graphically, we know what functions kind of look like, right? They pass that vertical line test. Numerically, what functions look like is they look like y equals stuff. It doesn't really matter what that stuff is. So y equals 2x plus 1. Y equals x to the third. Y equals 14x minus 132 x squared plus 16. It really doesn't matter because we're going to start with that y equals almost exclusively, okay, when we're graphing these lines. We're going to talk about the exceptions to the rule here in a little bit, in a couple of lessons. So let's talk a little bit about the functions that they're going to give us. Each function is kind of like a separate machine. When you feed values into it, it gives you different results. So the function that they start us out with is y equals 2x. Do you see that? Look for that on the page and pause this video and find it if you haven't yet. So for y equals 2x, that's the function that they give us. We're going to make a table of values, and then we're going to graph a line based on the results that we get on those values that we put in. So they give us x values of -1, 0, and 1, and this is a really good time to remember that every graph has an x part and a y part, and you're going to need to know both of those pieces of information in order to proceed. Right now we have the x part of the information. So how do we figure out the y part? Well, what we're going to do, and this is the reason we were practicing evaluating expressions, we're going to plug this -1 into the equation. So if I write y equals, and you will write, please, for all functions that you're evaluating, make sure you actually write it out. So this is going to be y equals 2 times x. Well, how much is x worth? Well, in this first time, x is worth -1. Make sure and put parentheses around your -1, because if you don't, what that looks like is y equals 2 minus 1, and that's not what we're doing, right? This is multiplication, not subtraction. So make sure and put your parentheses around values that you substitute in. So can we solve for y? Do we know what 2 times -1 is? Absolutely. So we get y equals -2. So when x is -1, y is -2. So I'm going to put that value in. Okay, let me go ahead and erase these because I'm going to rewrite it for the next one, and I don't have a lot of space. Y equals 2 times, how much is x worth now? We're looking at our second x, so our second x is 0. 2 times 0 is 0, so y equals 0. If you feel like I'm going too fast, pause it, rewind it, make sure you're writing them down. Play detective and try and figure out, okay, he did something. What did he do? Why did he do it? What I'm doing, again, is just plugging in different x values, the ones that I'm told to plug in, and seeing what y values come out. So when x is 0, y is also 0. So when x is 0, y is 0 for this specific machine, for this specific function. All right, one more. Y equals 2 times, what's x worth now? It's worth 1 for my last try. 2 times 1 is 2. So when x is 1, y is 2. So I'm going to put that 2 in my y column. Remember, all points are made out of x points, x parts, and y parts. Do we have an x part and a y part for all three parts? Yes. When x is negative 1, y is negative 2. When x is 0, y is 0. When x is 1, y is 2. So now we're going to interpret these results graphically by graphing the points and then connecting the dots in the right order. So one thing to remember is that this is called a linear function. Linear. And the important part of that is the first half line. If it does not make a straight line for your graph, something has gone wrong. Please go back and fix it, okay? So we're graphing linear functions using these tables. When x is, you know what, let's just use red. When x is negative 1, so I'm going to go back 1. Y is negative 2. I'm going to go down 2 and place a point. Now you'll have an actual grid when you're doing this, so please make sure and use that grid. I'm going to go backwards 1 and down 2. See that? Okay. Now I need to erase it because this looks like gobbledygook. Let me try again. So I went backwards 1 and down 2, and I put a dot. That's my first point. 0, 0 is my second point, so it doesn't move side to side, and it doesn't move up and down, and then I'll put a dot on. 1, 2, I'm going to go forward 1 and up 2. Now I'm going to connect these dots. There is only one line that can go through all three dots with a straight line. This is the graphical representation of y equals 2x, right here, this line. So numerically, y equals 2x, we can plug in x parts and get y parts for it, but we can actually graph the line, and that's what this looks like. This is y equals 2x. Okay, so that is the first example on that first page of the guided notes. See if you can do the other examples from the guided notes. I'm going to go ahead and move on to Slope Man. Let's go ahead and move to a grid line. So what Slope Man is he's a way to kind of remember how the different kinds of slope go. So let's talk about it. This is a positive slope. Because it goes up from left to right. For those of you who had the Adventures of Slope Dude, I'll make sure that link is posted in there. The Adventures of Slope Dude calls this puff, puff, positive, puff, puff, positive, puff, puff, positive. The other side here is nice, negative. So it goes downhill from left to right, so that's a nice slope. Nice, negative. This is on page, I think it's 4 of the notes. And then the flat part here, I like to say Oklahoma and Kansas have no slopes. They are flat. They have 0 slope. And so You see those zeros that I made? In The Adventures of Slope Dude, he says, "This is zero fun. This is zero fun." Because he's just having to work his way across the flat parts. And then he gets to the ledge and he says the worst curse word in math: undefined. And so if it's straight up and down, I'm using a U for that undefined. And the reason that we use that U will be more apparent later. But just remember that these are the different categories of slope. So if it goes uphill, it's positive. If it goes downhill, it's a negative slope. If it's completely flat, then it's a zero slope. And if it's completely up and down, only completely up and down, that's an undefined slope. Okay? So go ahead and pause the video and label the lines below SlopeMan as positive, negative, zero, or undefined. You have 4 lines, 4 ways to label it. Please label those lines. Okay, I'm going to assume that you have done that and that you have unpaused the video because we're going to finish this up. So again, when we're talking about graphs, oh, that's terrible. Let me try again. That's still bad. I apologize. I am not an artist, but artists have a hard time drawing straight lines too sometimes. Okay, close enough. So there are 2 pictures at the top of your page that starts talking about slope. It's the page after SlopeMan. There is a blank spot on the y-axis that's supposed to have a sun. The sun rises, and so this is the rise part of the slope, because the formula for slope is rise over run. How far up and down does it go versus how far side to side does it go? So we've got the rise part here, and then you have a picture of a runner right here. And this is my run. How far does it go side to side? The other way to write this is by saying the change in y over the change in x. If you don't want to write deltas, that's okay. You can just write the rise over run. We're going to come out with an actual formula for this later for those of you who aren't familiar with delta, so just hang in there. So rise over run. How far does it go up and down versus how far does it go side to side? When we were talking about slopes, you know, if it's super duper flat, that is a zero slope, right? That has nothing at all. What if we had a slope that just went up just a little bit versus a slope that went up a lot, really fast? I would say that the red is not a really steep slope, and I would say that the green is a very steep slope. So if we're assigning numbers to these, if you think about it, we're probably going to name the red one a small number, maybe even a fraction. And if it's a really steep slope, maybe we'd name it with a big number. Whoops, I'm going to use green, a big number like 6. So the red line has a shallow slope, the green line has a steep slope, and we can give those numerical terms, right? So that everybody knows exactly how much it slopes. So that's what we're going to be practicing here. We're going to be practicing actually calculating what the slope is and not just looking at it and saying steep or shallow or positive or negative. Let's get a little bit more specific. Okay, so on this line that they have, I'm going to draw a generalized version of it, but we're going to use the points that they use on the next page. There are 2 points, so we want 2 places where it really cleanly crosses the grid, so that we know, okay, well that is exactly -3, -2. That is exactly 0, 0. That is exactly 3, 2. So let's go ahead to the next page, and then we're going to come back to this page, okay? So hang on to that, don't lose it. So the points that they decided to pick were at -2, -1, and 4, 3. this is how much it goes up and down and left to right. Because the slope is going to stay the same no matter where you take the points. So it doesn't really matter which points you pick, so long as they're very precise measurements. So let's start figuring out how much it goes up and down. You can see on the notes on the paper, I said, okay, well, if I have a point here and a point way up here, this is going to go up 1, 2, 3, 4. Now I'm just using pretend units. I know that doesn't really match up with our grid. But it goes up 4, and then they said, okay, now it goes over 6. 1, 2, 3, 4, 5, 6. Again, I'm using made-up units because I'm referencing the actual notes. So let's take a look at what that makes this. So let's look at slope. Slope is how much it goes up and down over how much it goes left and right, right? Rise over run. Let's start using numbers now. I'm going to go ahead and erase this. The rise is, how much did it rise? It rose 4, right? So it rose 4. How much did it run? Well, it ran 6 units. 6 units forward. So that's 4 over 6. Can we simplify 4 over 6? This is where fractions come in handy. I can simplify 4 over 6. I can divide them both by 2. And so my actual finished slope, because we always use the reduced form, is going to be 2 over 3. This is the slope of my line. It's 2 over 3 because it went up 4 and forward 6, and then we simplified the fraction. Okay, so let's go back up to that page that you were on where it says identify 2 points, x1, y1, x2, y2. Let me show you a great little secret. Every time you're going to need to use points, I want you guys to label your points. So this is my x stuff, this is my y stuff. Do you see those little numbers on the bottom right-hand side? Those are called subscripts. So superscripts are like exponents. They're written above the number. Subscripts means it's written below. That's the literal translation. Sub, below, script, written. So written below, right? So I have 2 pairs of x and y points. How do I tell the difference between the 2? Well, we give them numbers, and that's what subscripts are for. So this is my x1 because it's my first x. This is my y1 because it's my first y. This is my x2 because it's my second x. And this is my y2 because it's my second y. So identifying the 2 points, my x1, y1 is -2, -1. My x2, y2 is 4, 3. See how that works? So we give them little numbers so that we can tell the difference between the different x parts and the different y parts. Okay, but going back, we can see that we could just count the squares, right? It went up 4 squares, it went forward 6 squares, the rise was 4, the run was 6. That's a fraction because it's rise over run. We can simplify the fraction, and then we get our 2/3. It's a positive 2/3 because it's a positive slope, right? It goes upward from left to right. So there's a lot to remember here. Remember to rewatch the videos, or to go on the internet and find more videos about slope, or to go to Khan Academy or Desmos, or there's a lot of different places you can go. So make sure, do what you can for those. And when you're ready, actually, you know what? We'll do this one together. When you're ready, go to the last part of the notes, the last page of the notes, and that bottom half, let's go ahead and do that together. So I'm going to make my graph again, but I'm going to actually try and make it correct this time. So it goes up to 6, 6, 5, 4, 3, 2, 1, 0, and then down 1, 2, 3, 4, 5, 6, and then it's going to go back 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I've got my little graph here, my x-axis and my y-axis. Let's go ahead and do this. I'm going to use a smaller brush here for a second. So we have the points 0, 3, and 5, 4. Oh, sorry, 0, -3. That's an important distinction. 0, -3, and 5, 4. These are 2 points, and they want me to graph the line that passes through those points. If I have just one point, I can draw a bunch of different lines through that, right? But if I have 2 points, there's only one straight line that can go through both, and I missed them both, but you get the idea. So we're going to take a look at these 2 points, and we're going to graph our points so we can graph our line. Let's go ahead and do that. And then we're going to use that graph to find the slope. 0, -3. Let's go ahead and graph this. I'm going to label it because I know I'm going to be using it. So this is my x, this is my y, this is my x, this is my y, and I should have been using a smaller brush, so let's try that. This is my first x and my first y. This is my second x and my second y. Okay, so let's go ahead and graph the points. 0 has 0 side-to-side movement because there's no x movement, and then -3 for the y. So I'm going to go down 3, 1, 2, 3, and I'm going to make my point. This is 0, -3. That's my first point. My second point is going to be 5, 4. I'm going to go forward 1, 1, 2, 3, 4, 5. And I'm going to go up 1, 2, 3, 4. And I'm going to make my point. So now that I've made my 2 points, I need to draw the one and only line that's going to connect both of those points. It has to be a straight line because this is linear functions. And I didn't do a great job, but it's not a terrible job. There's the line that goes through both points. So let's go ahead and try and find the slope. Well, you know what? They already gave us points. All we have to do is count the movement, right? So at 0, 3, what's our definition of slope again? Our definition of slope is rise over run. So how much does it go up and down? Here's my, oops, let's use a different color. Here's my up and down. Here's my side-to-side movement. How much does it go up and down? How much does it go side to side? What's my rise? What's my run? Well, let's count them. So starting from one point, 1, 2, 3, 4, 5, 6, 7. So it rises 7. It runs, starting again from where I left off, 1, 2, 3, 4, 5. So it runs 5. Both of these are positive because I went up 7 and forward 5. Can I simplify this? I cannot. So my slope is going to be 7/5. So I hope everybody was able to find this useful. Please keep these notes handy. Please use your notes on your quizzes and tests. And we will continue on next time.